Hey physics, this is Mr. Hausman. We're going to take a look at page 12, problem solving with speed and velocity. I'm going to zoom in here. We're going to take a look at number 3 in case you need a little extra reinforcement or a little practice with the sequence or the thinking process. So when we take a word problem, and I understand that many students tell me that word problems are the hardest part of learning science and math, but what I find is that what we need to do is read the sentence once. You arrive in class 45 seconds after you leave math class, which is 90 meters away to the left, okay? So which way are you moving? Are you moving to the right or the left? Let's not overinterpret this, but basically we know that you're moving 90 meters left, okay? And we also see that there was another quantity that was given, and we are in a section where really the only quantities that we could be looking for are distance, displacement, time, and of course, speed and velocity. So how many people remember all the symbols for those? Because you can write out each of these quantities using symbols. And this page is all about velocity. And so let's figure out what we have. 45 seconds, when I measure seconds, that must be a time measurement. There's no direction to time, so we'll just write it as a scalar. 90 meters away to the left. Well, are you moving to the left? Are you moving to the right? Let's just take it on face value and say that our displacement is 90 meters to the left. Now, did anyone realize that you could have, I'm going to change color, left, right, is this way, and, whoops, let's do a better color with that. Let's go red. Left means to the negative side, right, of a graph, right? Left is negative, right is positive. So you could either write left or negative sign. Now, let's keep going. Let's think about what formula we're going to pick. We're trying to figure out how fast did we travel. You could have calculated speed, you could have calculated velocity, but because we're given a displacement, it makes more sense to calculate a velocity. So we're going to write that and say that's our unknown, right? So this is called writing our given and our unknown. From that list, you can now take a look at the equations that are at the top of the page. I'm going to erase this list because they're not really part of the problem, but I notice there's two formulas. Let's do it. V equals distance over time, or velocity equals displacement over time. And what you notice is that the list on the left shows us that we have a displacement and a time, so we're going to pick this formula, right? You don't need to write both, but it's a choice. And right now there's only two choices, but there we have it. Now what you can do is you've picked your formula and you've written which formula you're going to use. Now we're going to do substitution. And the most common mistake is people forget to write the V, the velocity. Even though that's the unknown, you still write in the unknown. And the displacement goes on top, negative 90 meters. The time goes on the bottom, 45 seconds. And if that's not easy for you, take out your calculator and divide 90 by 45, and you're going to get 2 meters per second to the left, right? Negative, or the left. And that tells you you did not run. You didn't sprint. But you wanted to get there, and you got there at a velocity of 2 meters per second. So not too fast, not too slow.